Hi, this one's going to be interesting. We're going to take a look at a level 2 7 kilowatt electric car charger. This is the one that I'm going to install to fast charge my Ioniq electric car at home. So this is an electric car charger in quote marks, and we'll get into that. This is the My Energy Zappi, and it's designed and manufactured in the UK. So hi to all my viewers in the old dart, and we're going to take a squiz at this. We're going to take it apart, and I'm going to explain how these electric car chargers work, because this is not actually a charger as such. It's what's called an EVSE, or an electric vehicle supply equipment. The charger is actually in the car itself, or at least for these AC chargers, which this one is. This is a single phase AC charger. It does come in a 3-phase model, but my home only has single phase, and also my Ioniq electric car only has a single phase charger built in. And you'll notice I just said the car has the charger built in, because this is not the charger. The charger is actually built into the car. It's not in here. This basically is just a glorified relay with a 1 kilohertz generator, but being a bit harsh, there's a lot more engineering that goes into these EVSEs. So any AC charger for an electric car like this, be it single phase, 3-phase, or just the regular wall outlet one that actually comes supplied with it, just your regular 240 volt 10 amp jobby, none of that Yankee rubbish, and then these are all AC chargers, and it's simply supplying the AC directly from your grid pretty much into the car, and the actual charger itself is built into the car. Now this differs for the fast charging DC chargers. There is no DC charger circuitry inside your car. Basically, the car just has a relay in it that connects the internal battery pack through straight to the charging connector, and then the external, 50 or 150 kilowatts or whatever the high-powered DC charger is, that actually is an external charger. But this one we're going to take a look at, this is a level 2 AC charger, and this is just an EVSE, or an electric vehicle supply equipment. So like I said, this is a My Energy Zappi, fairly highly regarded. They're one of the leaders in the industry, and yes, there is nothing in there. This one has a fixed lead attached to it. You can get one that actually does not have a fixed lead, but I wanted the fixed lead. I didn't want to dick around with that. So this is the Type 2 AC charger connector, also known as a Menikes connector as well, because that's the company that actually first developed this, I believe. So this is the standard here in Australia and also in the European Union as well. And the Yanks have their own standard, which is the SAE J1772 standard, which the signalling, as we'll talk about in a minute, is basically the same between them, but the physical connectors and other, slight differences and stuff like that. Anyway, those Yanks are weird. So what we've got here is a protective earth pin in the middle. We've got neutral here, and we've got the active here, or the phase 1. If you're using a 3-phase, then you've got the 2nd phase and the 3rd phase, but they're just not fitted in this particular connector. And we've then got 2 control pins up here, and this one is called the PP line, which is the proximity pilot pin, and then this one here is the CP, or control pilot pin, which basically tell the car what type of charger you've plugged into, how much power is available, and stuff like that. And we'll go into details of that after the teardown, and we might try and measure some stuff on here. So this Menikes plug is the IEC 62196 standard, and the US do actually have this, but it's under the SAE J3068 standard. I'm not sure what cars in the US use it. I'm not up on Yankee land what's happening there. So basically what happens is you plug this into your car, then your car looks at a 1 kilohertz square wave on the control pilot pin here, and the duty cycle of that determines or tells the car what is the maximum power that it can actually draw from this, and then the internal charger of the car is supposed to obey that and not exceed the limit, so that you don't blow up your wiring and your cables and blow your fuses and blow the arse out of your EVSE here. So these EVSEs actually can be as simple as like just a 1 kilohertz generator and a relay to switch the mains, and that's, there's more to it. The rest of it's like protection type stuff. So anyway, it does do a couple of other things, but basically the control pilot pin on the IEC 62196 standard between here and Earth, if we actually measure that, so this is designed for single phase 32 amp, so we'll find that the standard for this, so it should have a 220 ohm resistor across the proximity pilot pin and the Earth here, and we can actually measure that just to verify it'd want to be. Have they supplied me the correct model? I hope so. Should get, yep, 220 ohms, bingo. And you can have various other resistances on there to indicate other maximum currents available. But this one, designed for a 32 amp single phase 240 volt Aussie outlet. Just as a bonus, this is what a single phase 32 amp Aussie connector looks like. I don't know, is this the standard in your countries? But anyway, this is the three pin one for the single phase, and there you go. That's it. Cool, huh? So I rather like the design of this My Energy Zappy here. It comes in a nice outdoor weatherproof case. It's got, I had to screw this on the bottom. This is like a cable rack because this is a wrap thing, because this is a fixed thing. So I mount this on the wall of my garage, and then I can just wrap the cable around here. And then it's just, as I said, it's just got the dummy thing in here. So just keep that in place like that. It doesn't do anything electrically, it just holds it in place so it doesn't flap around in the breeze. Nice touch. There you go, made in the old dart. This is 230 volts, although my house and my lab, they run about 240 to 245 volts. So I'm getting right up there on the upper limit kind of thing. And it's got a residual current, basically earth safety thing built in. That looks like 6 milliamp. And it's also got Penn fault isolator. I don't know if that is a requirement here in Australia. Leave it in the comments if you know, but I believe it is in the UK and some other countries. Penn basically stands for Protected Earth and Neutral, and this basically will detect if there's a earth breakage fault upstream from your house, somewhere in the street or something like that. It'll actually detect that. I believe like there's various methods to actually detect that, and it will actually trip that, because you don't want somebody touching the metalwork of the car, for example, when it's charging, and then for the earth to break, and you can get all sorts of unbalances, and you can get a little bit of a zappy. Get it? Mere old week. You can get a zappy from the zappy if it didn't have Penn isolation. Oh, goodness, that's terrible, Muriel. So anyway, let's open up. This is just a protective cover on it, and screws to install it. Look at this. It's got that is the saddest ass Aussie sticker I've ever seen in my life. Look, it's cut. Look, it's like one of the stars is chopped out, and look, from the Southern Cross, it's upside down, so all the electrons are going to fall out, and it's like not even like it's not trimmed properly. Oh, that's just no, that's an insult. That is an insult. That's Gonski. Sacrilege. And you'll find, because, as I said, this is not a charger, it's just basically a glorified, more than a glorified relay, but it's basically just got relays and protection stuff in it. There you go. There is not much at all. There's just a main board. It's got a little daughter board there. Not sure what that does. And we got some big ass. Oh, look at those. Oh, Panasonic jobbies. Thank you very much. Some big ass relays. What are they rated at? 35 amps, thank you very much. So they've got 3 of them, and basically power in here, so single phase in here. The 3-phase board will be different, of course. It's more expensive, it'd have to be bigger, more relays, everything else. But yeah, your single phase in here, and then just your relays to switch it. Now, because of these are double pole single throw jobbies, you can see, well, you can probably just see the pins down there. This is switching both the active and the neutral here, but so is this one as well. It's also switching the active there and the neutral, and this one up here is switching the earth in. So why they've got effectively 2 in series, and I can't see anything tapping off here, so I can only presume that's for extra safety, I guess. You've got 2 of them. just in case one of them, fuses shut or something like that. That'd be my guess. So there's our 6 square millimeter copper coming in. I'm probably only going to be drawing a 29 amp absolute maximum, I believe. But anyway, you can set it in software on the Zappi to have any sort of maximum current you want. And if you want to know why I got this Zappi model against others, is that this one actually is solar aware. So I've got a little current clamp here. I'm going to have to install that. That'll install on the incoming grid connection. And you've got to install it the right way around. It should have an arrow. Yep, there it is. This charge is intelligent in that it knows how much excess solar power you've got that would normally be going out to the grid and getting paid a pittance for, and then it can modulate the charge current to the car when it's charging and guarantee that you're only charging your car with excess solar from your own solar rooftop. And that's just great. I'd love to be able to charge my car knowing, guaranteed, that all of it is coming from the solar. So the whole idea is you come home and you plug in your car, and let's say it's nighttime, then this thing is going to detect that there's no excess solar available, obviously, because it's night, and so then it's just not going to charge the car. And as soon as the sun comes up at like 7 a.m, you start producing some excess solar, all the other appliances in your house are off and stuff like that, it'll start charging the car at whatever rate you have available. I'm not sure of the granularity of it, but is that a word, granularity? Anyway, yeah, it will modulate the charge rate up to the full 32 amps, 7 kilowatts. Of course, my home solar system is normal 8 kilowatts. So in the middle of summer, I should be producing, at peak, about 8 kilowatts or so. So assuming I chew less than a kilowatt in my house, I should have the full 7 kilowatts available to charge my car up. But yeah, anyway, I thought that was really cool, and everyone recommends this. It's really good. It's well made. It's made in the old Dart. Anyway, as you can see, the cables are terminating in ferrules here, which then go into the big cage clamp terminal box. They got proper cage clamps, not that little leaf spring rubbish. I can show you that here. There you go, proper cage clamp. Beautiful. And this is how it's doing its RCD. You can see the active and neutral are both going through this clamp here, and then it's able to measure any imbalance in that. So under normal non-fault conditions, of course, all your current flows from your active through to your neutral. So if you got current flowing in this direction like this, and then this direction like this, out the other wire in a full loop, they cancel each other out. So this current clamp is going to measure zero. There's going to be zero output from it. But as soon as some fault condition occurs, some earth leakage, rain got in somewhere, or somebody's touched something, something's failed somewhere, then there's going to be an imbalance in the current between the active and the neutral, and then you will get either a positive, depending on which way, you'll get either a positive, negative output from your current clamp here. So it's able to measure that, and it's calibrated to trip at 6 milliamp. And you can see that the protective earth here has its own current clamp as well. So I assume that's part of the pen protection system. So anyway, that's all very nice and dandy. So you can see there's only 4 wires going in on a charging cable, active, neutral, earth, and then the CP or control pilot. So the proximity pilot here, and you can see that labeled down on the board there, PP, PP. The proximity pilot pin is not connected. So that 220 ohm resistor we measured before, that must be physically within the connector. This goes off to a front panel LCD, which I'll show you in a minute. This says it's a protection board, so I'll take that out and show you in a sec. But there you go, that's just a 405 something, so that's just an analog mux. And yeah, they've just got some little passive stuff around there, little op amps or something like that. So yeah, that's doing some of the measurement. Now over here, look at this. This looks schmick and expensive. This is a Recom DC to DC converter module. It's probably one of those potted brick jobbies. 24 volts, 830 milliamps there. So that's basically powering this thing. And they've got another transformer there, so I don't know what that's doing. I've got a big ass MOV in there, so that's nice to see. Beautiful. So is that a common mode choke and X and Y class caps there, and curiously there is a little relay there, and an optocoupler. So, I don't know. I have to reverse engineer this to have a squiz at what's going on there. I'm not going to do that in this video, but anyway, that's interesting. AC input terminal block, and then this is another eSense thing. This has lots of options. In fact, it has a wireless current sensor option, or although it comes with the wired one, so it supports up to 3 current clamps here, and it can actually measure your supply as well, so it can give you that sort of detail. But its basic operation, it only needs the 1 current clamp, which goes on the grid side there. So there's that protection board. I can't read that on the LCD here. Why it's got a little bit of like capped on tape over that, I'm not entirely sure. But anyway, so obviously they're offboarding their protection circuitry onto this dedicated board, and that probably makes sense because the protection is based on regulations which could vary from country to country. So you don't want to go, you know, changing your main board or anything like that for different countries. So I suspect that's why they've whacked that on the dedicated board like that. So for different countries, they can just whack in whatever protection circuitry it might have, you know, different current trip ratings or whatever it is, and that would be programmed in there. So that's got its own micro to handle all that. By the looks of it, it'll do its own measurement and do its own thing. Nice. So you'll notice that there wasn't really a processor apart from the protection board there. That's because the processor must be on this main display and button board up here. Yes, that is a little antenna there because it has as I said, a wireless clamp interface, and it's called Harvey. I'm not sure what standard they use or whatever, but anyway, yeah. So if you don't want to run your cable, or it's, you know, too hard, you can't do whatever, you can actually get a which is quite novel because it's actually powered from the current clamp itself, which is really interesting. It's basically an energy harvesting thing which powers the transmitter, and this is the receiver here, and it can just receive the current clamp. And there you go. It's just got a little light window here, and you can see that the LEDs on there, they'll light up different colors, and that just like charge indication and stuff like that. But apart from that, there you go. Yeah, it's one big ass graphical LCD. It displays like a little car and stuff. And there you go. There's the wireless connection up there. I got no idea what that is, but, you know, leave it in the comments if you want to know. Little backup battery there for real-time clock. And the micro, must be hidden under there. PIC24F for the win. All the microchip fanboys go wild, and the good thing about that is that you can probably still buy those in the current component crisis. So yeah, winner. Right, so let's just power this up on the bench here and see if we can measure stuff. It's in, verifying, my energy's up. RCB board test, startup. We're in. That's a pretty nice display. EV disconnect, yep, no electric vehicle, no grid, no nothing. So I haven't read the manual on this, but yeah, it's in fast mode at the moment, which, well, timeout. Fast mode at the moment, which means that it doesn't have to follow that eco, like the solar thing, which is eco mode. So I don't know, is that, yeah, eco mode, there you go. So I think, yeah, eco plus mode is where it guarantees that it only uses energy from your grid. Whereas if you want to, you know, the sun's not out or it's nighttime, you just need to charge at the fastest possible rate, then there it is. You put in fast mode, Bob's your uncle. It does have a stop mode. I didn't think it did, but charge settings, you should be able to set like the maximum charge. I don't know. Yeah, there we go. Eco Plus settings, manual boost, smart boost. And the range here, well, that's going to vary between vehicles. So I think hopefully you can program that. So I'll have to program that for the Ioniq. Eco Plus settings, minimum green level. There you go. Stop, delay, plug-in charger. Eco Plus, look at that. You can start and stop at different import and export powers. That's rather nice. And then you've got like timer modes as well. That's really nice. Ah, there you go. It tells you your pilot PWM. That's fantastic. I was going to actually have a look at that, but isn't that nice? It'll actually tell us what the PWM is. And presumably that's measured, or, well, because it's generating it. It knows what it's generating, I guess. Whether or not it like measures that as a feedback, I don't know. There you go. This is nice. There's my lab voltage. Generating consumption and stuff like that if you put the extra current clamps on. Importing. It's pretty oh, what was that? That had Aussie something. Oh, yeah, Australian Eastern Standard Time. So that's pretty comprehensive. Yeah, there's that Harvey thing, the remote current clamp. Okay, what I've done now is I've just removed the input earth on this thing. I just want to see what happens if I power this up. RCB to, yep, nope, no error whatsoever. It has no problem with the lack of earth on the input. But I guess it's not surprising, because if you go through, oh geez, I'd have to, geez, there's a half-hour whiteboard tutorial in its own right, how all this sort of stuff works. But yeah, just the earth on the input itself, because there's no fault current or anything like that, it doesn't know there's an issue yet. Actually, I just checked to see if they have any info on this. I did actually find a video with one of the R&D engineers or someone at myenergi talking about, it's very extensive, very detailed, about all the various protection modes that this goes into. So I'll link that up here and down below. I haven't watched the full thing, but like, whoa, overload. It's probably got all the detail you could possibly want on all the various standards and protection modes that this thing covers under. It's just absolutely incredible. Okay, so what I'm going to do now is I'm going to experiment with this sucker and see if we can get it to actually simulate a car plugging in. Now, as I said, it all happens on the CP or control pilot pin here, and this is basically outputs a 1 kilohertz square wave. And as I said, the duty cycle of that will then indicate to the car what the maximum charge current it can take is. And there's a formula for that. I'll put it up here. Here you go. So now here's a diagram of stole it from Wikipedia about basically what's going on here in terms of the car. So basically it's the control pilot pin relative to earth here. So I've got two wires sticking out, and you'll notice I've got a diode over here and my decade resistance box. So it's basically a diode and resistance in there, and then the EVSE here will be able to determine that the car's actually plugged in based on the value of resistance on there. So it's a nominal 2.7k here after the diode here. And the reason that they've got the diode is because let's say that you got water, you know, it's raining or something, you got water into your connector here, then of course that can simulate a resistance. That can appear as a resistance, and then that could actually turn on your, it can activate the relays in here and can switch the power through and attempt to charge the car, and you don't want that. So the diode just adds some asymmetry in here to the waveform, and we might be able to see that. I'll try and hook a scope up as well. Just can't get it all in one shot, that's all. But anyway, so that's the reason for the diode, and then it switches a 1.3k in parallel with that, which gives you about 880. So let's dial that up to 880, something like that, and then we'll be able to switch between those two, basically. Right, so I'm going to power this on, and I've got it just set to 10 meg here, so it'll just appear open to the charger. It won't know the difference. So let's power it up. Doo-doo-doo-doo-doo-doo. It's very 8-bit. I love it. Right, so I set this just 2.8. I think that's going to be near enough to, we can go down to 2.7. There you go. Okay, so I'll release the 1 meg, the 10 meg here. There you go. Ta-da! I've got waiting for EV, okay? So it's detected that it's plugged in, but it's now waiting for the car. Okay, so if we go back to give about 880, here we go. Ta-da! There we go. It's switched on, it's green, it's RCD check-in, charging. It's now charging, but the car's not actually taking anything, as you can see over here on the display. But in theory, the car should be taking power. And then if we go back, I'm not sure at what point it like unbalances, but you know, whoop, charge delayed. Okay, I think that's a software thing. It's got a charge delay thing in there, which, yeah, I don't know. I haven't set this thing up with, haven't RTFM'd yet. Charge delayed, I don't know, the relay clicked again. Something's going on. I don't know. Yeah. But anyway, there you go. Cool, huh? You saw how that just the diode and the resistance value on there detected that the car was plugged in with the 2.7k, and then once you put the 1.3k in parallel with that, then it determines that, which is 880 ohms through the diode, then it determines that, yeah, well, let's start charging. So it switches the relays inside there, switches the mains through, and that's basically, you know, all this thing does. It's just a smart relay, pretty much. And there we go, we're waiting for EV mode with the 2.7k, and there you go, you can see No, it's because it just went into restart mode. Oh, okay. Yeah, no, there it is. There's your 1 kilohertz square wave. There you go. You can see that the duty cycle 53% there, which I think corresponds to the full 7 kilowatts, which is what it's set up to by default, or they're basically 32 amps. Aha, in the advanced settings here, you can set up the supply grid for the device itself. Ah, yeah, 31.8 amps. There you go. Let's just say 10.2 amps, shall we? All right, let's try that again. Ah, there we go. Got it. You didn't believe me, did you? There you go. So the duty cycle is now only 17% there. So that tells the car, please do not exceed that, 10 amps or whatever, based on that formula. There's a bit of give or take there, a bit of how you're doing, but it's gonna, the whole idea is that it doesn't exceed the maximum wiring limitation, maximum fusing limitation, and whatever installation that you've got, and the charger. Oops, so there you go, it's vanished. It's got some delay restart thing, but there you go. Cool, huh? Okay, so what I want to do now is just check what happens if I remove the diode, see if there's any fault detection on here. All right, there you go. Nothing. It's just detected that, well, there's nothing there. It's not giving me any error, but the good thing is that it's not going to start the charging. Yeah, it doesn't matter if I go to 880 or whatever. Yep, it's just not going to do it. So yeah, it's doing its job. So there you go, that's the basics of how the Control Pilot signal works there on the IEC 62196 and SAE J1772 or whatever it is, and the SAE J3068 standards. There's all these different standards for different countries, but I believe like all that is very similar. There could be like, minor differences, but that's how it all works. If you disconnect it, it knows it's disconnected like that. When you plug it in with the 2.8K, it knows it's, there we go, waiting for EV to do its thing, and then we can put that into charge mode. Cool bananas, huh? So there you go. I hope you enjoyed that video, found it interesting. But this is my first time playing around with one of these EVSE chargers. So it's really, I've been using my little piddly 10 amp 240 volt jobby at home, but I haven't played around with the signals and stuff like that. So that's really cool. And in theory, you could actually design and build your own one of these really, fairly simply. In fact, there is an open, it's the Open EVSE, it's called. And the reason I didn't get that one is because it kind of sort of might have integration with the solar and stuff. I'm not sure, it's all just dicking around. This one's, everyone recommends this. Everyone says it's really nice. And so I thought I'd go with this. But I do have the physical connector now, so I could actually play around with the Open EVSE. If you wanted me to, I can simply disconnect this one because it's not going to be permanently wired installed, and I can play around with either do-it-yourself stuff or Open EVSE. But there's not too much more to play around with here. This is just the basics of how it works. It's pretty simple. It's just a smart relay with, ground fault protection and residual current protection and stuff like that. And this one's a little bit smarter in that it can use your excess solar based on a current clamp on the grid. So anyway, subscribe to my EEV Blog 2 channel if you want to see after I've installed this. I might actually see if that wiring heats up, how much I know it's going to heat up in the roof, how much it heats up. Put that sort of videos on my second channel. I think I'm just hundreds of subs away from 100K subscribers. I get my YouTube Silver Award for my second channel. Well, that's if they'll give it to me anyway. Over on EEV Blog 2. Catch you next time.